What does that open this up to? Go for it.
Imaginary number.
Imaginary numbers may be part of. They don't have to be, but if you see a place where the I could be used, use it. If I said real, you can't use it. Complex, you can. You guys will try this one. And I think my 4 o'clock session, students probably saw something like this. And then I thought about a student also who said something like grouping. I'll try this first. I'd like to find the 6 zeros that function, they call them zeros, that function has. Now, I've got some students in class right now. I notice when I score these papers, I've got some students right now who could jump into this without much help from me and get down the way. On the quiz, I'll probably have, though, for all students, please try this. Let U be something, and therefore rewrite this function that's raised to the 6th power, rewrite it as a quadratic, raised to the 2nd power. And therefore I'm going to use quadratic formula, factor, completion of the square if it's a quadratic. This is not a quadratic. And what's that U representing, or what should I let U be? Usually it's caught in that middle term. So in this case I'm going to try x cubed. This is a little repeat of what we were doing last time I saw you guys in this class. To confirm that, x to the 6th could be written as this, x cubed squared. That's not x to the 5th, it's x to the 6th. So x to the 6th, my first term could be expressed like that. Therefore, if u is representing x cubed, you could write this as u squared minus 7u when I substitute that. And now you turn this into a quadratic. And we all know how to deal with quadratics. We've dealt with quadratics since I met you guys. I'm going to factor. Some students like to use quadratic formula. It's up to you. I think it's going to be a minus 8 and a plus 1. Split this up, guys. You are now considering for the u 8 and a negative 1. But you got to hold on because we're not quite finished. The original function was written in terms of x. They want to know what is x. I gotta go back and keep in mind what u was representing. You guys, this says x cubed is equal to 8. And down here with the replacement, x cubed is equal to a negative 1. Now the solutions to those two in the green is obvious. This has to be a 2. This is going to be a negative 1. Is that true at this point? Don't let me make a mistake. Is all that true? Now, someone in class tell me, and I'm sort of lead you into what the bonus from Wednesday will look like. Can anyone tell me how would you convince someone that x cubed is equal to 8? One of the answers is 2. How would you say to convince someone one of the answers for x cubed equal to 8 is 2? Cubic. 2 times 2 times 2 is 8. And that would convince someone, oh, it is 8. So x must be 2. It just so happens, though, in order for us to find those 6 answers, we have right now 2, negative 1. These 4 are missing. That's what we were discussing last week. My 4 o'clock session, remember quickly what to do here. They're telling me that I should go back to x cubed is equal to 8, move that 8 over, and rewrite it as x cubed minus 8 for a reason. And now this takes the form of a cubed minus b cubed. And guys, since it is a cubed minus b cubed, I'm going to actually write this 8 to make it look even better. In the green there, it's 2 cubed. So it looks exactly like a cubed minus b cubed. You will not know what to do unless you know the formula. And I think my 4 o'clock session gave the formula to me. Guys, we'll put the formula on this side if you don't mind. A subtract b, a squared plus ab plus b squared. look that up. That's for a cubed minus b cubed. Erase that, get something over here. So that's equivalent to this. You gotta know your formulas there. A subtract b, a squared plus ab plus b squared. Guys, if I apply that to the green, here we go. A subtract b, in this case, would be x subtract 2. A squared would be x squared. Using my formula. A times b for this green would be minus 2x. Is it minus 2x? Plus 2x. And then b squared, 2 squared is 4. And this is for x cubed minus 8. I'm looking at it. Did we use it correctly? Did we use the formula correctly?
Yes.
Now, can someone tell me, before I go any further, it looks like the formula's been done correctly. If you have time on the quiz Wednesday, how could you maybe have all these formulas in your mind and get them mixed up? How could you convince yourself that, Professor, this is this? What could you do? Did we use the formula correctly? What could you do if you have the time just to convince yourself before you go any further that maybe you have a sign wrong in here somewhere or something? What could you do to convince yourself? Yes, Lisa?
Complete the square.
Tell me again.
Complete the square.
Not complete the square, but how can you just convince yourself right here at this point that that formula is correct at this point? I haven't gotten to the point where I'm trying to find the answers yet. That's just right there at that point you were saying, Professor, I better convince myself I may have a sign wrong or a number wrong. Yes?
Just multiply.
Multiply it out. Now, whether or not you're going to have time, you got to multiply this green out. I'm going to do it just to make sure I'm right. So if all that's correct on the right-hand side there in the green, it should give me x cubed minus 8. And guys, here goes quickly. Distribute property. I'm going to distribute the x on these three terms. So we end up with x cubed plus 2x squared plus 4x. That's that x out front distributed through. Now you also have to distribute the negative 2. The negative 2 has to be distributed on the green three terms. That'd be a negative 2x squared. I'm going to line these up. Minus 4x minus 8. And these two will cancel. These two will cancel. I'm left with x cubed minus 8. It checks. So just to make sure, as a student, I just check my work. Just to make sure I did not have a sign wrong or a number wrong. So this is good here. So guys, that's just a little check there, the purple. This is a little multiplication. Now, since we're assured of that, when I split this up to finish up, of course you want to set this equal to 0, and you want to set this equal to 0. Just a little recap. This gives me a 2. No problem. We got 2 earlier. The other part is a nice little quadratic. It's going to give me 2 more answers, and this little quadratic will not factor. X squared plus 2x plus 4, use the quadratic formula. I'll do it quickly. Negative 2 plus minus square root. I see a 4. Subtract 4 times 1 times 4. All over 2 times 1 is going to give me a 2. Got to remove it out here so you guys can see it. This is negative 2 plus minus. Guys, underneath there it says 4 subtract 16. I hope I don't have a mistake. That's a negative 12. All over 2. Let's hope there's no mistakes in all this. Negative 2 plus minus. Now, what are you going to say about square root negative 12? Are we finally into the i's? Does anyone know what square root negative 12 looks like, bringing in the I and also simplifying?
2i over 3.
Okay, it's 4 times 3, that's 12. So you can say all together, maybe 2i radical 3.
Yeah, that's what I said.
All over 2.
Oh, yeah.
Is that true? And then, we walked out here at the very end, you can simplify this final answer. Not the final answer is coming up now. I can simplify this by dividing everything by 2, reducing down by 2. You're going to end up with a negative 1 out front. 2 divided by 2. This 2 divided by 2 will give me an I. radical 3, and we really left out the bottom part, denominator 2 divided by 2 is 1. I was figured out. And those are, if there's no mistake, 2 more answers up here to work with. Negative 1 plus I radical 3, negative 1 minus I radical 3, and you got 2 more answers. We have now 4. How many are missing? I need 2 more. All 6. Now, before I jump in and try to complete this, this answer and this one came from, my goodness, where was it? Were we trying to find a number that when you cube it, would give you an 8? Is that what we originally started out with somewhere in here, somewhere x cubed equal to 8? Is that true? Now I'm going to do this, guys, for you. How did you convince someone? Someone told me right quickly to convince someone that 2 is one of the answers. You cube 2, you get 8. How can you convince someone that that strange number also works? Negative 1 plus I radical 3. How could you convince someone that that also works? Not just 2, that strange answer also works. What would you have to do? What are you going to do? I'm trying to lead you to the bonus.
Cube it?
You're going to cube it. Good luck. You're going to cube that. Now, if I were a student and I had not been around math for a while, or I've been around math and did not enjoy it as much as you're enjoying math now, look at this. You're supposed to do this. Good luck. In other words, I'm doing this. Watch closely. So I'll give you a hint for the bonus. We all need the 6 points. I'm supposed to cube that. Now, I think most students would say, Professor, it looks like a mess. It is a mess. So what I'm going to do first is maybe multiply these 2 together, get that out of the way, and then worry about the end, the last part, factor on the term, on the end for a factor. Guys, to multiply these 2 together, you can use, some of you guys use something called FOIL, or just expand it out. So I see negative 1 times negative 1 is 1, that's no problem. I see this is a negative I radical 3. Oh, I'm in trouble here already. This is a negative I radical 3. Not let me make a mistake, please. And then, can someone tell me what last times last, these 2 multiplied together in this expansion will give me? I radical 3 times I radical 3. 3, square root 3 times square root 3 is 3. 3I squared. But what's I squared equivalent to?
Negative 1.
Negative 1. So altogether it becomes only what?
Minus.
Negative 3. That's 3I squared, and that's 3 times negative 1, negative 3, since I squared is equivalent to negative 1. I's radical, what? Radical square root or square root negative 1. You square it, you get negative 1. Now, combine like terms, not pleasant. Let me put my numbers together in fact also. 1 minus 3 is negative 2. So I got negative 2 minus 2I radical 3. Like this. Guys, I just collected terms up here. 1 subtract 3, negative 2, put the I terms together. Am I correct so far? I'm getting a little nervous. Now what am I supposed to do? I still have the purple on the end. I'm not finished. I still have this. Do it again. Oh, we're having fun. I can multiply that out. Now, I'm gonna just multiply it out like you guys use FOIL or distributed property or expand it out. I see, first times first is a positive 2. Is that true? Inside, you want to take these two together, guys. That's a positive. Looks like, do not let me make a mistake. I'm on top of the board here. Looks like it's a positive 2i radical 3. Yes or no? These two. I think it's a negative 2i radical 3. Yes or no? True? And then last times last, this term, where am I? Yeah, this term times this term. Help me out, guys. Can someone tell me what this green times that purple down there would give me if I have everything lined up correctly? This one times this one. Help me out. Or maybe I have mistaken in doing what we've done here. Was there a negative 2 here and this somewhere?
Positive 6.
Did I copy this down wrong? First, negative 2i radical 3, I got that. Negative 2, oh, no, you're okay. Guys, anybody can tell me what this is? When you multiply it together? Guys, you tell me. Oh.
Positive 6.
Yeah, what was it?
3.
Well, let's see, is this a negative 2i squared? I'm hearing something. Negative 2i squared times what, 3? I see negative 2i squared, was it I squared? Hang on, I got to look at, I've lost myself now. Oh, these two.
Yeah, 10 squared.
It's a negative 2i squared, and square root 3 times square root 3 is 3. Is that negative 6 times a negative 1, which is 6? Yes or no?
Yes.
Please tell me it is. These two terms cancel out. Oh, wait. So I'm left with what? 2 plus 6 is what?
8.
Wow.
Now go out and let your friends know. Go ahead and ask them what, give me the 3 zeros that will satisfy x cubed equal to 8. They'll definitely tell you 2, unless there's something wrong with them. They'll definitely tell you 2. 2 times 2 times 2. But I doubt, you have some of these math 7, math 8 students we have. I doubt if anyone's going to say professor. Also, that when you cube it, will give you an 8. I didn't make a mistake, did I? Did I make a mistake, anyone? Did it work? Okay. Now, I don't have the time to find the last two. You sort of go through the same process, but to find the last two, guys, you go here and rewrite this one as x cubed plus 1. Just move the 1 over. And this one takes the form of a cubed plus b cubed. Hey, you can help me out. Remind me of the formula.
A squared. Sorry.
A plus b, okay.
A plus b.
Then a squared.
A squared minus ab.
You got it?
Plus b squared.
There you go. And that's one for a cubed plus b cubed. And that would have to be applied here. If you're patient and you get the answers, those will be the last two for this. And you should be finished. Olivia, did we get all that right? Woo! That's a busy problem. And guys, could you do something like that for me? Of course you could. So that's what I wanted to do for it. Look at the board space it took. And I see students still looking at it. Whoa.
So that's just a way to check it.
What's it now?
That's a way to just double check it.
Yeah, exactly. And that bonus problem on the quiz on Wednesday might be one where I give the answer to you. You may not even have to find the answer. I just ask you to confirm it is an answer.